All right. So we're starting 14.3 today. We're technically a day behind, so I've got to figure out a day to catch up, but today is not one of them. You're going to have a quiz tomorrow on 14.1 and 14.2. Okay? 1 is the graphing, and then 2 is the trig identities, where you have the sine squared plus cosine squared is 1, the one with cosecant, and the one with tangent and cotangent. All right. Today, 14.3 is verifying trig identities. And I started this at the end of the lecture that I showed you on Friday, or that we did on Friday, or I recorded for those of you that weren't here. These are really, I think they don't use the word because you're in shock from geometry, but these are algebraic proofs. Okay? But they flow a lot differently than geometry proofs. Okay? So, we have learned so far a few identities that you can use. Okay? We've learned that sine of x is 1 over cosecant of x, right? Which another way to say that is cosecant x is 1 over sine of x. So there's two formulas for that. We know that cosine of x is 1 over secant x. Cotangent x is what? Oh, I wrote that backwards, but still it works. It's 1 over tangent x. Or tangent x is 1 over cotangent x. You can do that in either way. So, I wrote that backwards. Cosecant x is 1 over sine x. Secant x is 1 over cosine x. And tangent x is 1 over cotangent x. Okay? We also have that tangent x is sine of x over cosine of x, right? And therefore, cotangent x is cosine x over sine x. And then we learned 3 new ones. Sine squared x plus cosine squared x equals 1. Tangent squared x plus 1 equals cosecant squared x. And cotangent squared x plus 1 equals, this is secant. Tangent goes with secant, sorry. And this cotangent goes with cosecant. Okay? You need to have all these memorized. All right. What we're going to do is, all we have is this, and we're going to prove some trig identities. Okay? Identity just means that one thing equals another. Okay? So, let's do a few of them. So the first one, it would say, verify that sine squared x over 1 minus cosine x equals 1 plus cosine x. All right. So all you can do when it asks you to verify, you only work on the left side, and you have to simplify the left side until it looks like the right one. Okay? So, so we're wondering, does sine squared x over 1 minus cosine x, if you put a question mark with equals with a question mark over it, it means does that equal 1 plus cosine x? Well, if I look at this, I say, okay, what's over here that's not over here, trig function-wise? No, just trig function. There's a sine over here, there's no sine over here, right? So we need to get rid of sine over here, and hopefully once we get it to all cosines, it will simplify to that. Okay? So what is a formula with sine and cosine that we could substitute? Sine squared plus cosine squared equals 1. So what does sine squared equal? If you took that identity and solved it for sine squared. Right, so in place of sine squared, we can write 1 minus cosine squared x. Does that equal 1 plus cosine x? Well, a lot of times when you're working it, I would write cosine squared as this. Does that equal 1 plus cosine x? Well, at this point, nothing cancels, right? You can't cancel the 1's because those are terms, not factors. Can't cancel the cosines. But the top is the difference of two squares. What if that had been 1 minus x squared? What would it factor to be? 1 minus x, 1 plus x. So 1 minus cosine x squared factors to be 1 minus cosine x, 1 plus cosine x. What happens now? You can take the question mark off because it works. So what you have proven that no matter what x is, if you take sine of it and square it and divide it by 1 minus cosine of that, it's the same as just doing 1 plus cosine the angle. All right? We good? Okay, let's do another one. Now, this one was nice because just working on the left, we could get it to look just like the right. Sometimes it's not going to work that way, okay? Because sometimes what's on the right is not a simplified version, it's actually a more difficult version, or more complex. So let's look at what happens with this. No. Oh, well, kind of no. So we'll get to it. All right. Yes.
You know how you only supposed to work on one side?
Uh-huh.
What if you don't figure it out and you like work on the other side?
Well, that's what I'm about to show you. Okay. So, what if I ask you to verify that secant theta is tangent theta over sine theta? Okay? So, we can only work on the left, right? So what's the only thing we can do with secant theta? What can we change that to be?
1 over cosine theta.
Right. So we could make this 1 over cosine theta and say, does that equal tangent theta over sine theta? And we're stuck, right? Because we don't have anything, can't factor that, can't simplify the fraction, okay? So here's what you do. When you get stuck, you pull out a scrap sheet of paper, okay? And I used to have a teacher that called this because he always did the work on the board, he called this his secret board, okay? So you have scrap paper because you're not allowed to work on the left side or the right side, but you can to kind of get a cheat sheet of where you need to go, okay? So on this other sheet of paper, let's work on this. So tangent theta over sine theta. Well, what is tangent theta? So we could write that as sine theta over cosine theta all over sine theta. Right? Then how would we simplify that fraction?
Multiply by 1 over sine theta.
You could think of this divided by this, so you multiply by the reciprocal. Or an easy way to simplify a complex fraction is multiply top and bottom by the common denominator, which is cosine. Okay? So if you took this, either way works. Okay? If you want to do sine over cosine times 1 over sine, that works. Or you can multiply top and bottom by cosine, and that works. Okay? So if you multiply top and bottom by cosine, you get, so that was our first one. You get sine theta over cosine theta times cosine theta over sine theta times cosine theta. What happens then? That cancels, and you have sine theta over sine theta cosine theta. Right? Which is what? 1 over cosine theta. Okay? Which is what we have over here, right? Once you get what you have over here, write the steps in the reverse order over here. Okay? Think about it like this, okay? You're trying to get from one side to the other. You build the bridge this way, and then you get stuck. So you go over here, you build the bridge to there, but then when you're going over, you go in the reverse order to get there. Right? So this is working from there, then you work from there, but then that completes the bridge. Okay? So what we can do here is, in place of 1 over cosine, I can write sine theta over sine theta cosine theta. Right? Because how would we get from there to there? Multiply top and bottom by sine. Right? Then in place of that, I could write this. So in place of sine, I'm going to write sine over cosine times cosine. So that becomes sine over cosine times cosine over sine theta cosine theta. Right? Okay. In place of that, I can write, the cosines would cancel, right? So I can write sine theta over cosine theta over sine theta. And in place of that, I can write Okay? See how that works? So you work to here and you got stuck. So work on this side, but then put it in the reverse order over here, and you'll get them to be the same. Yes.
Okay, I know how we showed the word the other day. Do we have, like, do you want us to show that?
Want us to show what?
Where we
Like the side part?
Yeah, the
No.
side part.
That's not part of your answer.
Okay.
You're only supposed to work on one side. So technically this is cheating, but it's an easy way to do it. Okay? And it's legal cheating, if that makes sense. Well, you just have to say, what can I do to this to make it look like that? And you'd have to come up with these steps on your own, which is pretty impossible. Okay? So, oh, sorry. Not work? No. I'm not that mean.
What is
I probably just keep trying to work it out. Keep going.
Yeah. You good?
Yes.
Okay. Let's do another one.
Oh, you got it.
I knew I didn't want to do it. I'll take this out.
Okay. So, as tangent to the fourth, yes.
Is that a B?
Yes. It's a beta, but yes.
Beta.
Oh, so you were saying beta.
Mm-hmm.
Oh, I thought you just mispronounced it beta.
No, it's B, beta. All right. Okay, so we can only work on the left side. Well, that's the difference of two squares, right? So that could be 1 minus tangent squared beta, 1 plus tangent squared beta. Okay. Well, we do have an identity that has tangent squared in it. Tangent squared would be secant squared minus 1. Right? So in place of tangent squared, we can write secant squared beta minus 1. Then we can distribute this negative, right? And so that becomes 1 minus secant squared beta plus 1. Oh, this is going to work out really great. 1 plus secant squared beta minus 1. Okay, 1 plus 1, usually 2.
Hold up. Where you get them?
Wait a minute, I just got lost.
Yeah, I got lost.
Where?
One, okay, the one and one. Okay, I see it.
1 plus 1 is 2. 1 minus 1 goes away, and that's just secant squared beta.
I didn't see the other one. That's why I got confused.
Oh, you just got rid of the inside parentheses.
Yeah, just distributed the minus and distributed the plus. Then you can just distribute. 2 times secant squared beta is 2 secant squared beta. Minus, what's secant squared beta times secant squared beta? Secant to the 4th beta, and there you have it.
I feel like I've been here the whole time.
No, I forgot what it was.
went back in my work, I be like, why people check my phone?
Okay.
It's so many numbers and letters.
Let's try two more.
I feel like I'm learning square root. So it's just, this would just be like, the questions would be verified.
Yep.
Yeah, I just gotta take this.
When did you say we had that?
Quiz tomorrow on the other two sections, not
The videos that you said.
and the one before y'all left of the graphs.
Oh, the
Yep.
Oh, the
All right. So verify.
did Miss Queen give you our homework?
No.
Because we typed it in before we left.
No, that's okay. I'll get it. She may have put it in there. I just haven't checked it yet.
I was going to be like, hold up.
Brittany sent me a picture of hers, so I had hers.
my mom made me do
I turned mine in.
She even said that in the email. My mom's making me do this.
Yeah, my mom was trying to reach out to the picture my Spanish on too.
Okay.
I'm gonna have to start keeping a document address my Spanish.
Yeah, this one.
All right. So there's two ways to attack this one. One, a way that works every single time, that works for any verify, is if you write everything in sines and cosines. Because you know how to do that, because secant you could write as 1 over cosine. Cosecant you can write as 1 over sine. Tangent you can write as sine over cosine. Cotangent you can write as cosine over sine. So you can write everything as sine and cosines. So that's one way to do it. Okay? So let me show you kind of the two ways you could do this one. All right? First one would be to write everything as sines and cosines. So what would tangent squared be?
Sine squared x over cosine squared x.
You got it. Over, what would secant be?
1 over cosine x.
Minus 1.
Oh, yeah,
Does that equal 1 plus 1 over cosine x? Okay, now we have a complex fraction here. How can we get rid of it? Common denominator. So we can multiply top and bottom by cosine squared x. So we've got sine squared x over cosine squared x times cosine squared x over 1 over cosine x minus 1 times cosine squared x. Right? Does that equal 1 plus 1 over cosine x? Well, what does the top become? Just sine squared x. Right? What does the bottom become? Well, what is cosine squared x times 1 over cosine x?
It's just be cosine x, right?
Just be cosine x. Because you got cosine squared over cosine. So that's just cosine.
Cosine x. And then
Minus
cosine squared x.
cosine squared x. Does that equal? Okay. Now at this point, I would notice we only have cosines on the right. We don't have any sines, right? So at some point, we got to get rid of that sine squared. How could you write sine squared with cosines?
Oh, sine squared x plus cosine squared
Is 1. So this would be 1 minus cosine squared x over cosine x minus cosine squared x. right? Now we need to factor the top and the bottom. Okay.
What did you get that one?
It's in one of the equations.
Sine squared plus cosine squared equals 1. So sine squared would be 1 minus cosine squared. If you take sine squared plus cosine squared equals 1 and solve it for sine squared, you would get 1 minus cosine squared. So in place of sine squared, I'm writing 1 minus cosine squared. Here. This, if you solve that for sine, look up here, Rick. This, if you solve that for sine squared, what would it be?
For sine squared?
Uh-huh.
1 minus cosine squared.
Sine squared is 1 minus cosine squared x. She got it.
I feel like I kept going.
No, you're fine. Hey, there is no kindergartner that can do this. Okay? So,
Yeah, I'm just.
the top is the difference of two squares. So that's 1 minus cosine x times 1 plus cosine x. The bottom, you can factor out a cosine. And you're left with 1 minus cosine x. Right? Those cancel. So you've got 1 plus cosine x over cosine x. Anytime you've got a complicated numerator over a simple denominator, you could write this as 1 over cosine x plus cosine x over cosine x. Right? So that is 1 over cosine x plus 1 equals 1 plus 1 over cosine x. Is that making your brain tingle? Well, I'm going to work this one the other way. Okay?
What does it?
Uh-huh.
What's another one?
The other way is to use the other identities.
Oh, yeah.
Getting it to sine and cosine works every time, but sometimes there might be a shorter way using the other identities. Okay? And in this case, it does end up... Now, sometimes using the identities makes it longer. So you really... There's not a... You do it this way every time. So, let's do it the other way. What is an identity that has tangent squared in it?
The tangent squared plus 1 equals secant squared.
So, what could we... If you solve that for tangent squared, what would you get?
That would be secant squared x minus 1.
So this one actually ends up being much shorter. But like I said, that's not always the case. Sometimes the sine cosine route is the shorter route. Because the top now is the difference of two squares. Right? So what does that factor to be? Secant x plus 1, secant x minus 1.
And that's secant.
So we have secant x plus 1. Does that equal 1 plus 1 over cosine x?
Yeah, because
Secant is 1 over cosine x plus 1 equals 1 plus 1 over cosine x.
Look at that.
So, unfortunately, there's not a way that I say if you do this every time, that's the shorter route. Because sometimes sine and cosine is the easiest, shortest route. Sometimes using the other identities is an easier route.
I don't even understand this. I think I understand it.
The difference is sine and cosine works every time. Okay? So it may not always be the shortest way, but it works every time. Okay? This sometimes works, sometimes doesn't. Okay, let's do one more. Now, this one is unique in that what?
You
Can't do anything on the left. We can't rewrite it as sines and cosines because it already is. And there's no identities that just have a sign in it. There's sine squared. There's no identities with just a cosine. So we're stuck. So we go to our secret paper.
Secret paper.
All right.
Can we write that on the secret?
Yep. So this we could write as sines and cosines, right? So that'd be 1 plus sine theta over cosine theta over secant is 1 over cosine theta, right? Then how can we simplify? So we're going to multiply top and bottom by cosine theta. So we've got 1 plus sine theta over cosine theta times cosine theta over 1 over cosine theta times cosine theta. Right? Then what happens there? On the top, cosine theta times 1 is cosine theta, right? Plus cosine theta times sine theta over cosine theta is sine theta, right? Over 1, which is same as over here. So now you write it in the reverse order. So the first thing I would do is change the order of these. So I would say cosine theta plus sine theta, does that equal 1 plus tangent theta over secant theta? Then put that over 1. And you could do that in one step. Okay? Then you could technically factor out a cosine to get the step before. So you'd have cosine theta 1 plus sine theta over cosine theta, right? That is the same as that, over right? See how these two are equal? Does that equal 1 plus tangent theta over secant theta? Well, the cosines cancel. And you're left with 1 plus sine theta over cosine theta over 1 over cosine theta. And then you're done. Because that is 1 plus tangent theta over secant theta. Which these are just the steps of your secret board written backwards. Yes, somewhere. I'll find it for you. Okay, homework is... Oh, I need to...
have math in the morning, and by the time we in school, I be like, man, I don't know nothing from this morning. I be looking at my mother.
Oh, the homework tonight is a worksheet, so I'll need to go copy it. So your homework is
God is so good.
14.3 worksheet and quiz on 14.1 and 14.2. Okay? Let me stop the recording.
Recording?
I was recording.
Hi, Angelo.
Hey.
See, I was
I'm sorry.
I was praying that he was.
Yeah, you posting on YouTube, right?
I was like, she's sleeping.
Yeah.
Okay, yeah. I'm about to go home, about to watch them back to back. Do
Meditate.
both these worksheets. So I can take this quiz tomorrow and make decent